Hello, students. Today we're going for the third application of derivative. Okay, already two I have covered. First one is the rate of change of quantities, then increasing and decreasing function. Okay, now the third application that is tangents and normals. Okay, tangents and normals. Now, first thing, what do you mean by tangents? Normal. See, suppose this is a curve. The equation of the curve, it is given by y is equal to f of x. Okay. Then this is called as the tangent line. The tangent line is the curve. Let the point. This is the point of intersection of the curve with this line. Uh, let this point be x0, y0. Okay. So the tangent line intersects the curve at this point x0, y0. Okay. Now, what is normal? Normal, you know very well, which is perpendicular to the tangent. So this is called as the normal line, tangent line and normal line. And this normal, it is perpendicular to the curve. Okay. Now, if this is fx, then what is the tangent? Okay, at this point x0, y0. Tangent to the curve. Okay, or it's called as the slope of the tangent. Okay, this is the tangent to the curve. Okay, tangent to the curve is given. This is the tangent to the curve. Okay, and equation of curve is given as y is equal to equation of curve is y is equal to f of x. Okay, the equation of the curve. Then, what is the slope of the tangent? Okay, slope. Slope is nothing but it's dy by dx or f dash x. Okay, so fx is the function given for the curve, then f dash x is the slope of the tangent. Hence, at at x0, y0, slope or slope of the tangent, which you call m, is equal to dy by dx at x0, y0. Or you can say f dash x0. F dash x0. Okay, dy by dx. Since y is a function of x, hence you will get dy by dx. What you will get? You will replace uh, x with that point x0. Okay, so this is the slope of the tangent. Now, slope of the normal. Okay, slope of the normal you know that normal is perpendicular to the tangent. Okay, so if a line, okay, is perpendicular, if this slope of this line is m1, slope of this line is m2, then you know that m1 into m2 is equal to minus 1. Okay, if two lines are perpendicular to each other, then product of their slopes is equal to minus 1. Hence, slope of the normal. Okay, the slope of the tangent. Slope of the normal, how to find? Now, slope of tangent into slope of normal is equal to minus 1 as they are perpendicular to each other. This implies slope of normal, slope of normal is equal to minus 1 by slope of the tangent. Okay, so slope of normal is equal to minus 1 by slope of the tangent. So once you find out the tangent dy by dx, so minus 1 by dy by dx. You can write it as minus 1 by f dash x 0. So this is about your tangent and slope of the chord. Next, equation. Okay, equation of tangent line. Equation of tangent. Okay, equation of tangent. As you know, tangent is a line. It is a straight line. So what is the equation of straight line? Now, if x0, y0 is the point, then y minus y0 is equal to slope m into x minus x0. So you can write it as y minus y0. Slope is f dash x0 into x minus x0. Okay, this is the equation of the tangent. Then equation of the normal. Equation of the normal, same, y minus y0 is equal to equation of normal is minus 1 by f dash x0 into x minus x0. This implies y minus y0 into f dash x0 is equal to or then just multiply f dash x0 into y minus y0 plus x minus x0 is equal to 0. Okay, so this is the equation of tangent and equation of normal. So you have four things: slope of tangent, slope of normal, equation of tangent, and equation of normal. Just based upon this four concepts, we have to solve the problem. Okay, there are some. Let us discuss about some properties. Some special cases. Special cases. What are the special cases? You know that m. Okay, slope is equal to tan theta. Now, what is tan theta? Now, this is the tangent line. let this line is parallel to x-axis. Okay, then what is theta here? What is theta here? Theta is the angle subtended by the tangent with x-axis. Okay, so this angle is theta. Okay, so why we are taking tan theta? Now theta is the angle, positive angle between x-axis and the tangent. Then tan theta is the slope. Okay, so here tan theta is equal to, we are writing it as dy by dx or f dash x. So what is the special case? Suppose tangent is tangent is parallel to x-axis. Okay, the tangent is parallel to x-axis. So if it is parallel, then theta is 0. Theta will be 0. Okay. If it is parallel, then angle between the tangent and the x-axis, it is 0 degree. So if theta is 0, then tan theta is equal to 0. Tan 0 0. Okay, tan theta is equal to 0. Then equation of the tangent will be y minus y0 is equal to m into x minus x0. Okay, so y minus y0 m into x minus x0. So this becomes 0. Slope is equal to 0. If this one 0, then y minus y0 is equal to 0. This implies y is equal to y0. Okay, when tangent is parallel to x-axis, y is equal to y0. Okay, similarly, when tangent is parallel to y-axis, second case, if the tangent is parallel to y-axis. Okay, so here if tangent is parallel to y-axis, that means theta is equal to pi by 2. Okay, theta is equal to pi by 2. The tangent parallel to y-axis. Okay, so the angle between the x-axis and y-axis is 90. Here it is given parallel to y-axis, means so tangent is parallel to y-axis, so perpendicular to x-axis. So theta is pi by 2. This implies tan theta infinity. Tan theta is infinity. Now, what will be the equation? Now, y minus y0 is equal to uh, m into x minus x, or x minus x0 is equal to y minus y0 by m. Slope is infinity, so 1 by infinity is 0, hence this one 0. So x is equal to x0. Okay, this one you keep it in mind. When the tangent is parallel to x-axis, y is equal to y0, and when the tangent is parallel to y-axis, then x is equal to x0. Okay, now let us solve some problems. Without solving problems, without explaining the problem, you cannot have an idea, clear idea about this. Let us solve some problem. Okay. It is given. Let us solve question number 5. Question number 5 of your exercise. Find the slope of the normal to the curve. Find the slope of the normal to the curve. Find the slope of the normal to the curve. X is equal to x. X is equal to a cos q theta, and y is equal to a sin q theta. X theta is equal to pi by 4. X theta is equal to pi by 4. Okay. See. Find the slope of the normal to the curve. This is in parametric form. Okay. So here we will find x is equal to a cos q theta. See, slope means we need to find out dy by dx. This is given in parametric form. From that we have to find dy by dx. X dx by d theta is equal to a into cos q theta. This is 3 cos square theta with respect to cos theta minus sin theta. So minus 3a cos square theta into sin theta. Now dy by d theta. Okay, dy by d theta is a into 3 sin square theta with respect to sin theta. It is cos theta. Hence it will be 3a sin square theta into cos theta. Okay. Now dy by dx. This is dy by d theta upon dx by d theta. Okay. So dy by d theta is 3a sin square theta into cos theta by minus 3a cos square theta into sin theta. So 3a 3a gets cancelled, and sin square theta 3a 3a cancelled. Cos theta 1 cos theta cancel, sin theta by cos theta, it will get minus 10. Okay. So dy by dx is minus 10. It is given, find the slope of the normal to the curve at theta is equal to pi by 4. So dy by dx at theta is equal to pi by 4. It will be minus 10 pi by 4. This is minus 1. Okay. So in this way you have to solve. Next, another one. The equation, the slope of the equation will be given. Equation of the slope will be given, and you have to find some points. How to find the point of intersection? Like that one problem we will do. It is given that find the points on the curve. This is 13. Number 13. Find the points on the curve x square by 9, x square by 9 plus y square by 16 is equal to 1, at which the tangents are parallel to x axis, parallel to y axis. Parallel to x axis and parallel to y axis. Okay. So here you see, find the points on the curve. Function of the curve, the equation of the curve is already given, at which the tangents are parallel to x axis. Okay. So we have to find the point at which the tangent is parallel to x axis. So for that, first we have to find out the tangent. Okay. Now x square by 9 plus y square by 16 is equal to 1, or 144. 16x square plus 9y square is equal to 1, or 16x square plus 9y square is equal to 144. Okay, the equation. Now differentiating both sides, differentiating uh, with respect to x, we have 32x plus 18y with respect to y dy by dx is equal to 0, or dy by dx. Okay, dy by dx is equal to minus 32x by 18y. Okay, so dy by dx you got. This is the what? Tangent. Okay, slope of the tangent. The slope of the tangent is given. Here we have to find out the point when the slope of the tangent, okay, uh, is parallel to x-axis. At which the tangents are parallel to x-axis. So this tangent is parallel to x-axis. Just before this, I have said, okay, if the tangent is parallel to x-axis, that means slope is 0. So tangent is parallel to x-axis when dy by dx is equal to 0. Okay, that means minus 16x by 9y is equal to 0. This implies x is equal to 0. Now, when x is equal to 0, x is equal to 0, y is equal to, put the value here, 16x square, this will become 0. So 0 plus 9y square is equal to 144. This implies y square is equal to 144 by 9. This is 16. So y is equal to plus or minus 4. Okay. Hence the points are hence the point at which tangent is parallel to x-axis. Okay, is x 0, y plus or minus 4. So 0 plus or minus 4. That is uh, 0, 4 and 0 minus. Okay, this is one. Then second one, parallel to y-axis. Okay, so when it will be parallel to y-axis, if slope of normal is 0, means minus 1 by dy by dx is equal to 0. Nah? Or tan theta is infinity, dy by dx is infinity, or else you can take that the second year dy by dx is equal to infinity. Nah? So dy by dx is infinity, minus 16x by 9y is infinity. This implies 9y by 16x is equal to 0. This implies y is equal to 0. Okay, again put the value of y here. Y is equal to 0, then 16x square is equal to 144, x square is equal to 9. This implies x is equal to plus or minus 3. So the points are plus or minus 3, 0. That is 3, 0, minus 3, 0. Okay. So the point at which the tangent is parallel to x-axis is 0 plus or minus 4, and parallel to y-axis when it is plus or minus 3, 0. Okay. So like this, you have to solve the problem. Okay. Mainly based upon three things it will come. For objective type questions, simply find the slope of the tangent or slope of the normal. Then in 2 marks questions and in 4 marks, it comes like that. The point equation of the curve will be given. Okay. Then find the point at which it is some condition will be given, parallel to x-axis or parallel to y-axis. Somewhere it will be given that uh, this tangent, tangent is parallel to another line. Equation of another line will be given in that case. Okay, how to find the. So this is your third application. Okay, this is also an important application. Here, application of derivative in calculus, application of derivative, integration, and application of integration. These three very important. Okay, thank you.